Good evening and happy Thursday. We're finishing up tonight. All right, so we're going to start by looking at the product to sum and sum to product identities. And we conclude by looking at solving trigonometric equations. So alpha and beta are any two real numbers. Okay. So cosine of alpha times cosine of beta would be a half the quantity of cosine of alpha minus beta plus cosine of alpha plus beta. Sine of alpha times sine of beta would be half the quantity of cosine of alpha minus beta minus cosine of alpha plus beta. And then we have the two mixed, so sine of alpha cosine of beta and cosine of alpha sine of beta. Okay. So again, alpha and beta are any real numbers. So sine of alpha plus beta would be 2 times the sine of alpha plus beta all over 2 times the cosine of alpha minus beta over 2. Sine alpha minus sine of beta would be the same thing. You just switch the roles of the plus and minus. And then cosine of alpha plus cosine of beta would be 2 times cosine of alpha plus beta over 2 times cosine alpha minus beta over 2. Cosine of alpha minus cosine of beta would be 2 times sine of alpha plus beta over 2 times sine of alpha minus beta over 2. Okay. So that concludes all of the common identities. And so we had what? We had the properties to write everything in terms of sine and cosine, right? We have the cofunction identities. We have the Pythagorean identities. The even odd property. We had the periodicity properties, right? So sine cosine of 2 pi period, right? And tangent is pi period. And we have the sum difference identities, the reduction identities, the double angle identities, the half angle identities, and now these two, the product to sum identities and the sum to product identities. Right? So what I want to do is show that this is going to be tangent of 3a. We're going to use the sum to product identities, the one for sine and the one for cosine. And that's what we get for the sine. And that is what we'll get for the cosine. All right, 2 over 2. Now if we notice, this and this are the same, right? So that becomes 1. Right, 4a plus 2a, 6a over 2. Left with sine of 3a over cosine of 3a. And that is just tangent of 3a. And so start with sine of a minus sine of b over sine of a plus sine of b here. Going to use the summed product on sine, right? So the numerator is the difference. For the denominator, we use the sum. Right, the 2's drop out. So what's circled in green? It's tangent, right? It's sine over cosine. And then what's circled in blue? Right, cosine over sine is the cotangent. But isn't cotangent 1 over tangent? Right, so what we can do is we can write that product as tangent of a half the quantity a minus b over tangent of a half the quantity of a plus b. Right, and if you wanted to avoid confusion, right, you can put parentheses around that, right, to show that we're taking tangent of the whole thing. Let's start with the cosine cubed times sine squared. So what we can do here is factor cosine out of cosine cubed. Right, and then we're going to be left with a cosine times sine all squared. Right. Multiplication is commutative, right? So we can switch the order and write that as sine times cosine instead. But sine times cosine is 1/2 sine of 2x. Right, we now have a quarter cosine of x times sine squared of 2x. Use the reduction identity for sine. And just rewriting it. Distribute the cosine through. And so for this second term here, we can use the product to sum. Right, the 1/2, the quantity, cosine of x plus 4x, plus cosine of x minus 4x. Okay. You can factor out a 1/2. If I factor a half out of cosine, we're just left with 2 cosine. Then we get minus cosine of 5x plus cosine of negative 3x. No, I'm sorry, minus cosine of negative 3x. All right, so these two terms can be flipped, right? Addition is commutative, so order doesn't matter. But also, cosine is even. So cosine of negative 3x is the same as cosine of 3x. That allows us to write this expression as 1/16 times the quantity 2 cosine of x minus cosine of 3x minus cosine of 5x, which is what we wanted. And 1 plus cosine 2x plus cosine 4x plus cosine of 6x. By associativity, grouping doesn't matter. So why don't we group these two together? And then use the summed product. Okay. Using commutativity, I'm going to write the cosine 6x before this term. Right, and then simplifying, we're going to have 2 cosine of 3x, cosine of negative x. If we look at the 1 plus cosine of 6x, we can write that as 2 cosine squared of 3x, right? Using the reduction identity on cosine. And then using the fact that cosine is even, cosine of negative x is just positive cosine of x. Yeah, but now look, there's a 2 cosine of 3x common. Sum the product. All right, simplifying, this will become cosine of 2x. This will become cosine of x. Now just rewrite your terms. Oops, I forgot. There should be a times 2 in there. All right, so that should all be 4. All right, so I'm going to correct that. Right, and then we get the desired result. So the product to sum to product identities aren't really used that often. They will make a brief reappearance in either Calc 1 or Calc 2. Right, more likely to be Calc 2. Are there any questions on the product of sum to product? Okay. Now we look at solving trigonometric equations. Now, unlike the other equations that we've looked at this semester, right? So polynomial equations, rational equations, exponential, logarithmic, right? With trigonometric, we're now dealing with periodic functions, which means theoretically, if an equation has a solution, it's going to have an infinite number of solutions. However, most of the time, we're generally interested in the solutions within a particular interval, specifically from 0 to 2 pi. Right. So notice that that is what they're asking for. We're only looking for solutions between 0 and 2 pi. Right? Including 0, excluding 2 pi. Let's start with a real simple one. 2 sine of x minus 1 is equal to 0. Right? Well, that would mean that 2 sine of x has to be 1, right? Which means that sine of x has to be 1/2. So how'd you get pi over 6? Right, we are. But is that the only angle? So what's the other angle? Right? Which is what? Right. So you know it has to be quadrant 2, right? Because sine is positive. So what quadrant 2 angle is pi over 6 the reference angle of? And so we know that this angle here has to be pi over 6, right? So then what is that angle? It's 5 pi over 6. You can't just take the inverse sign, right? You can't just from here say x is the inverse sign of a half, right? Because that's not going to give you a complete solution set. It's a good starting point, right? But then you have to ask yourself, are there any other angles? Right, in this case, there is 5 pi over 6. Right? Sine of x times cosine of x equals 0. Well, zero property sine of x is equal to 0 or cosine of x is equal to 0. So where is sine of x equal to 0? And I agree, 0. And it'd also be pi over 2. I'm sorry, not pi over 2, pi. And then where's cosine equal to 0? Right, that would be pi over 2 and 3 pi over 2, right? That means x is in the union of the sets. So we have 4 solutions. 0, pi over 2, pi, and 3 pi over 2. Again, we use the 0 property. That would mean that either tangent of x minus 1 is 0, or 4 sine squared of x minus 3 is 0. we get tan x is equal to 1, or sine squared of x is 3/4, right? So tan x is 1, or sine x is √3/2, or sine x is negative √3/2. And now just go one at a time. Where is tangent equal to 1? All right, I do agree pi/4. Where else is tangent 1? All right, so you have to ask yourself, what quadrant are we going to be in? Oops. So that angle has to be pi/4. So then that would be 5 pi/4, wouldn't it? All right, now we need, okay, where is x or sine going to be √3/2? All right, pi/3. That to be 2 pi/3, right? Now negative root 3 over 2. Well, what quadrants are we dealing with? 4 and 3, right? So each of those angles has to be pi over 3. So then you just have to go, okay, so look at the quadrant 3. What is that angle? It's not 225. Be pi over 3 plus pi, right? Four pi over 3. Then we just need the quadrant 4. So let's do that in orange. So that would be 2 pi minus pi over 3, wouldn't it? Which is 5 pi over 3. Okay. Now we have tangent. So look at these. Look at those two sets. Do all of those values fall in the domain of tangent? Yes. So your solution set is the union of all three. All right, sine squared plus sine minus 2 is equal to 0. Well, let's do a change of variable. Let y be sine of x. Then what does this become? Yeah, y squared plus y minus 2 is equal to 0, right? And we know how to solve quadratics. Can this be factored? Yes, it can. We get y plus 2 times y minus 1 is equal to 0, which means y is negative 2 or y is equal to 1. But remember, we did a change of variable. So what this means is sine of x is equal to negative 2 or sine of x is equal to 1. Where is sine of x equal to negative 2? Oh dear. What is the range for sine? Isn't sine always between negative 1 and positive 1? That's a contradiction. Sine cannot equal negative 2. So that first equation has no solution, so we can just ignore it. Where is sine equal to 1? And that's the only place sine equals 1. So we have one solution, pi over 2. Okay, I just need to step away real quick to get another bottle of water. I'll be right back. Okay. 3 cosine squared equals sine squared. Right, so what we can do, divide both sides by cosine squared. Means that tangent squared has to be 3. Right? That would mean that tangent is either root 3 or tangent is negative root 3. So where does tangent equal root 3? And where else? Right, so what quadrant are we going to be in? Right, yes, 4 pi over 3. So we didn't need that. Right, now where's tangent? Negative root 3. Right, would be the others, right? So 2 pi over 3 and 5 pi over 3. Right, so this means that x is pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3. There's our solution set. So 2 sine of x minus cosecant of x equals 1. What would you rewrite it as? What would you do then? What I'm going to do is actually skip that step. Right, by recognizing that cosecant is 1 over sine, just multiply everything by sine. Which will give us 2 sine squared minus 1 is equal to sine. That allows us to write 2 sine squared minus sine minus 1 is equal to 0. Right, let y be equal to sine, just like we did before. Two y squared minus y minus 1 is equal to 0. It's quadratic. Right, so quadratic formula always works. But it'd be nice if we could factor this. Can we factor? And that would mean you have to use quadratic formula. But this actually can be factored. And factors of 2 are 2 and 1. Factors of 1 are 1 and 1. 2 minus 1 is 1, right? We can write that as 2y plus 1 times y minus 1. This gives us y is negative a half or y is 1. Which means sine x is negative a half or sine x is 1. Where does sine equal negative 1/2? We get 7 pi over 6. And also 11 pi over 6. Sine is 1 at pi over 2. Not 3 pi over 2. Sine would be negative 1 at 3 pi over 2. However, we multiplied through by a sine. So let's just check to see if all three of these solutions fit. Pi over 2 does, right? We get 2 minus 1 is 1. Right, so that one works. 7 pi over 6 and 11 pi over 6. Just check those. Right, so here's how. I'm going to do it because I'm just feeling lazy and don't feel like doing it in my head. 7 pi over 6. Oops. Escape. 7 pi over 6 minus cosecant 7 pi over 6. Right. So whenever you're using your calculator to do trig functions, you want to always make sure you're in the right mode. The TI Inspire, it's very simple to tell. See right up here? It'll tell you the mode. I'm in radians. It's also easy to change in the Inspire. All I have to do is click it. Right now it's in degree. Now I'm back in radians. That's close enough. So that works. Now let's just double check with 11 pi over 6. That works. So there's the solution set. Multiply through by a cotangent. Secant times cotangent. I'm sorry, it's not sine. Is cosecant of x, right? Secant's 1 over cosine, cotangent is cosine over sine. So that becomes 1 over sine, which is cosecant. One plus cotangent squared is cosecant squared. The range for cosecant all real numbers except those between -1 and +1. Meaning cosecant can never be 0. So we're allowed to divide by it. This gives cosecant of x has to be 2. Or sine of x has to be 1/2. Right, I believe we already solved that. So we get pi over 6 or 5 pi over 6. But we multiplied through by a cotangent. So let's just double check and make sure that both of these are indeed solutions. Oh dear. Of course, because it's using approximate arithmetic. Why do you do this? All right, so what's 2 secant of pi over 6? Okay, that's that. Now let's do tangent. Plus cotangent. They're the same. So pi over 6 checks out. All right, now let's just check 5 pi over 6. It was the other solution. That also checks out. So that would be our complete solution set. Okay. Let's multiply through by a tangent. Let's do a change of variable. So say y is tangent of x. All right, we're going to get y squared minus 4y plus 3 is equal to 0, which does factor. We get y is 3 or y is 1. So tangent x is either 1 or it's 3. Right? We already solved for when tangent is equal to 1. And we got pi over 4 or 5 pi over 4. Now, where is tangent equal to 3? Right? This is not so nice. So first ask yourself, what quadrants will tangent be equal to 3? Right. In other words, in what quadrants is tangent positive? One and 3. So if we take the inverse tangent of 3, that puts us in quadrant 1, right? So that angle has to be the inverse tangent of 3. We want this angle. So we just take the inverse tangent of 3 and add pi to it. So those are the solutions. Possible solutions. Now we have to check. Do they all work? Right? Because remember, we multiplied through by a tangent. So we just want to check and make sure that that didn't change anything. And so we had tangent. First, let's try pi over 4. Then plus 3. Oops, I don't want control. Plus 3 cotangent. Pi over 4. We want that to equal 4. That one checks out. Check out 5 pi over 4. That one works. Right, now we want tangent or inverse tangent of 3. Let's see if that works. That's 4, perfect. And then we have one more. And that works. So our solution set is all of them. Actually, I think this one's smaller. Okay. When we come back at 7:50, we will finish up. I will see you all at 7:50. And welcome back. All right, we're going to be finishing up with the equations. All right, next one we're looking at, cosecant plus cotangent is √3. Well, both cosecant and cotangent have sine in the denominator. So if we multiply everything through by sine, okay. Now, let's square both sides. And then use the fact that sine squared is 1 minus cosine squared. We can multiply everything through by 1/2. I change a variable to let y be cosine of x. And we solved this quadratic already. Did we? No, we didn't. We were very close, though. Bummer. Right, but at least we know it can be factored. we wind up with y being either a half, right, or y being -1. So cosine is going to be a half or -1. Oops, I don't want cosine x, I want x. Where is cosine equal to a half? We get pi over 3. And 5 pi over 3. Cosine is equal to -1 at pi. Well, we did a lot in this problem, right? First, we multiplied through by a sign, and then we squared both sides. So let's really make sure that these are going to work. Well, pi is not going to work. Right? Because we multiplied through by a sign, we're only allowed to do that as long as it's not 0. And sine of pi is 0. So that doesn't work. What about 5 pi over 3? That's also not going to work, by the way. Both cosecant and cotangent are going to be negative at 5 pi over 3. You can't get a positive by adding two negatives. So that doesn't work. Pi over 3 might work. Right, it's quadrant 1, they're both going to be positive. So let's go ahead and check. So we want cosecant. No. Cosecant pi over 3 plus cotangent pi over 3. That is that. And what's square root of 3? That checks out. We have a single solution. X is pi over 3. No, that's definitely too big. Go down one. Okay. Now, you know what? I'm going to go up one more. All right, cosine minus root 3 sine is equal to 1. Well, let's do some rearranging. Let's write this as cosine of x minus 1 equal to root 3 times sine of x. Then proceed how we did before, right? Square both sides. Right, then use the fact that sine squared is 1 minus cosine squared. Multiply through by 1/2. Do a change of variable. So we can write this as 2y squared minus y minus 1 equal to 0. Right, now that was one that we did solve, right? Wasn't this one? That was the one that was up here, right? Yep. So we got y is negative 1/2 of 1. So we're going to get either negative 1/2 or 1 for cosine, right? Cosine is negative 1/2. 2 pi over 3 and 4 pi over 3. And cosine equals 1 at 0. Well, we can immediately rule out 2 pi over 3. Cosine's negative, sine is positive. You're going to get negative minus a positive. No way that gives you positive 1. So immediately 2 pi over 3 is out. 0 could work. And 4 pi over 3 could also work. All right, so let's check them out. I don't even know why I'm doing this. 0 clearly works. Whatever. All right, so at 0, we get 1. That works. And 4 pi over 3 also works. So there's our solution set. Oh, bugger all. There we go. Okay. Let's multiply, not multiply, I'm sorry. Let's go ahead and square both sides. All right, 4 cosine squared, which we're going to rewrite using cosine squared being 1 minus sine squared. Right? Five sine squared minus 2 sine minus 3 equals 0. Use a change of variable. Five y squared minus 2y minus 3 equal to 0. This can be factored. 5 minus 3 is 2. That'll factor to 5y plus 3 times y minus 1. All right, and so we see that we're going to have y is negative 3/5, or y is 1. right? This will leave us with sine either being 1 or negative 3/5. If sine is 1, x would be pi over 2, right? If sine is negative 3/5, then what is x? Well, what quadrants would sine be negative in? Right, 3 and 4. So those are the two angles in question. But remember, we want angles between 0 and 2 pi. That is the inverse sine of negative 3/5. But that angle is not between 0 and 2 pi. In fact, it's going to be a value between negative pi over 2 and 0, right? So how can we get that to be an angle between 0 and 2 pi? No, we want it in the exact same quadrant. We want it to be that exact angle right there. We just add 2 pi. We now want to figure out this angle. Well, we know this whole thing is pi. And we also know that the inverse sine is negative. Right? So let's just say it's negative pi over 4. then this angle, if we're just measuring it with respect to this axis here, would be pi over 4. How do you get pi over 4 from negative pi over 4? Multiply by negative 1. So it's pi minus the inverse sine of negative 3/5. But again, we have to check, right? We squared both sides. Quadrant 3 is not going to work. This is negative. Sine is negative, so you get 1 minus a negative, which is positive. You'll get negative equals positive, which is nonsense. Which means this angle right here can't be a solution. Pi over 2 is easy to check. Cosine is 0. Sine is 1. 0 equals 0. Pi over 2 works. All that's left is to check this one right here. And we can ignore the 2 pi. What's the equation? There it is. Right? Because if it works for inverse sine of negative 3/5, it's going to work for 2 pi plus that, right? Because they're the same angle. They're coterminal. Remember that, the periodicity of cosine. That's 1.6. And that is 1.6. So that also works. All right, solution set, pi over 2. Or 2 pi plus the inverse sine of negative 3/5. Well, so far, all of the equations that we've been dealing with, perfect. Oh, you want to be like this. Okay, so I have to actually close you out. That's so annoying. Right? All of the equation we've been dealing with, right? The trig function have been of a single angle. See that? Cosine x sine x, cosine x sine x, cosecant x cotangent x, tangent x cotangent x. All right, secant x, tangent x, cotangent, so on and so forth. We're now going to look at what happens if it's something like 3x in this case, or like 5x. So we're going to look at sine of 3x being negative root 2 over 2. First, remember we want solutions to be between 0 and 2 pi. Multiply that entire inequality through by 3. And we want 3x to be between 0 and 6 pi. Think of this 3x as a single angle theta. Right, because that's essentially what we're going to do. That would mean that theta is between 0 and 6 pi. I'm going to leave 3x here. Right, but where does sine of theta equal negative root 2 over 2? What angles? So it's quadrant 3 and quadrant 4, right? So we'd have what? 5 pi over 4 and 7 pi over 4? Right? But we want all angles between 0 and 6 pi. So add 2 pi to 5 pi over 4. Add 2 pi to 7 pi over 4. That's now 2 full revolutions, right? That's now between 0 and 4 pi. Add 2 pi to 13 pi over 4. Add it to 15 pi over 4. That is now between 0 and 6 pi. Now just divide everything by 3, and those are going to be your x values. There's our solution set. By the way, we could have also just as easily used the identity that we looked at last evening, right? The one for sine of 3x. But that would have made this really more complicated than it needed to be. All right, cosine of x over 2 equals 1/2. So we could use the half angle identity for cosine, right? But again, that's going to make this more difficult than it needs to be. Divide everything by 2. X over 2 is going to be between 0 and pi. Between 0 and pi, where does cosine equal 1/2? Is there another angle? Is that between 0 and pi, though? So it's just pi over 3. So we have a single solution. X is 2 pi over 3. Right? Again, that was a lot simpler than if we were to use the half angle identity for cosine. Okay, so here we have a mixture. Sine of 2x plus cosine of x equals 0. All right, so what we're going to have to do here is either write both in terms of just x or both in terms of 2x. Well, the easiest one to do is to use the double angle identity on sine of 2x, right? Now factor out a cosine. we get cosine of x is 0, or sine of x is negative 1/2. Well, cosine is 0, right, at pi over 2 and 3 pi over 2. Sine is negative 1/2. 7 pi over 6 and 11 pi over 6. And there's our solution set. Okay. So here we have, again, a case where we have different angles, right? We have an x over 2 and we have an x. We have to write everything in terms of the exact same angle. So either everything as x over 2 or everything as x. Easiest is x, right? Use the half angle identity on cosine. Right, so half angle identity for cosine is plus or minus square root of 1 plus cosine x all over 2. And that's being squared. When you simplify, we get 1 plus cosine of x equals cosine squared. Cosine squared minus cosine minus 1 equals 0. If we do a change of variable, we get quadratic form. And this is one that we looked at already. It was unfortunately the day where Teams was down. So I posted the recordings from last semester. Now you have to use quadratic formula. You're going to get 1 plus root 5 over 2 or 1 minus root 5 over 2. Isn't 1 plus root 5 over 2 larger than 1? So that first equation is a contradiction. It says cosine is larger than 1, which is impossible. What about 1 minus root 5 over 2? Is that between negative 1 and positive 1? The answer is it is, right? And it happens to be negative. So if we're looking here, what quadrants are we going to be in? Right? 2 and 4. No. I agree with 2. We're going to be 2 and 3. If we take the inverse cosine of 1 minus root 5 over 2, we get that quadrant 2 angle. This angle here has to be the same. But we want this. So wouldn't that be 2 pi minus the inverse cosine? And we did nothing fancy, right? We just used an identity, which is always true. So that is our solution set. We're going to use the double angle identity on cosine. But remember, we have 3 of them. right? We have cosine squared minus sine squared. We have 2 cosine squared minus 1, and then we have 1 minus 2 sine squared. Since we have this cosine here, we'll use 2 cosine squared minus 1. All right, so 2 cosine squared plus cosine is 0. Factor out the cosine. Cosine is 0 for cosine is negative 1/2. All right, cosine 0 at pi over 2 and 3 pi over 2. It's negative 1/2. At 2 pi over 3 and 4 pi over 3. Again, we did nothing fancy. We just used an identity. And so they all are in our solution set. Okay. This one is going to be a bit of a pain. All right, let's write tangent in terms of sine and cosine. But sine of 2x, 2 times sine times cosine. But look, we have a 2 sine common. Multiply through by cosine of 2x. And also replace cosine of 2x with 2 cosine squared minus 1. Keep in mind, this is going to exclude now values where cosine of 2x is equal to 0, which is fine because we had tangent anyway, which does the same thing. Two sine of x is 0, or 2 cosine squared plus cosine minus 1 is 0. The first one means sine of x is 0. Here's what I'm going to do. Think of this as like a little side thing. Two y squared plus y minus 1. Can that be factored? It can. We've already seen it, I believe. All right, it's 2y minus 1 times y plus 1. So that's like a little side note that I'm going to use down here. But what I'm going to do now is do this, right? So if 2 cosine x minus 1 is 0, that means cosine x is negative a half. If cosine of x plus 1 is 0, I'm sorry, why is that negative? That should be positive 1/2, I'm sorry. And then that would be cosine of x is negative 1. Sine is 0 at 0 and pi. Cosine is 1/2 pi over 3 and 5 pi over 3. And cosine is negative 1 at pi. None of these make tangent of 2x undefined. So they're all in the domain of tangent 2x. So they're all solutions. So we have 4 solutions: 0, pi over 3 pi, or 5 pi over 3. All right, notice I don't need to list pi out twice. But it is a multiplicity of 2. right. Sine of 2x equal to cosine of 2x. Rewrite this to mean that tangent of 2x is equal to 1. And remember that since x needs to be between 0 and 2 pi, we need 2x to be between 0 and 4 pi. All right, so I do agree pi over 4 is one of them. For 0 to 2 pi, what's the other angle where tangent is equal to 1? Right, 9 pi over 4 is, we'll get to that later, right? So 5 pi over 4, yes. Now we add 2 pi. That's where the 9 pi over 4 comes from. And we'll also get 13 pi over 4. Right, now we're between 0 and 4 pi. Just divide everything by 2. And there you go. All right, sine of 2x equals cosine of 4x. We're going to use the double angle identity on cosine. And we're going to use the 1 for 1 minus 2 sine squared, right? Because we have a sine of 2x already. Right, so as with the previous problem, we're going to want 2x to be between 0 and 4 pi. We're also going to do a change of variable. Right, and we've already seen that y will be 1/2 or y will be -1. All right, so we're going to get sine of 2x is 1/2 or sine of 2x is -1. Where is sine equal to 1/2? Now, pi over 6 and 5 pi over 6. Now we just have to add 2 pi. So there's our 0 to 4 pi. Right now, where is sine equal to -1? All right, that's a 3 pi over 2. Then we have to add 2 pi. Divide everything by 2, and there's our solution set. Any questions? Okay. So a couple of comments. First, Monday is our last official meeting of the term. Right, I do plan on going over previous year's finals. I think I have 2 of them. I have last year's, and I think I have 2 years before that. So I'll go over those problems on Monday. Your Unit 5 test is due Monday at 6 p.m. Right? You have homework due tomorrow and Sunday. Then remember, your final will be posted Wednesday at midnight. Will be due Thursday by the end of the day. All right. Also, I had planned on getting quiz 7 graded today. Unfortunately, my son was home sick all day. So that kind of shot that plan. I'm going to try and get things graded tomorrow, but there's no guarantee because he's going to be home again tomorrow. So I will try and get quiz 7 graded tomorrow and possibly quiz 8. graded tomorrow and solutions posted, but again, that is not a guarantee. If I can't get it done tomorrow, it will be done Monday. Right. That shouldn't set me too far back. I might not be able to get the Unit 5 test graded until Wednesday morning as a worst case scenario instead of Tuesday morning like I had originally planned. But it will still be graded in plenty of time for you to, use it as a reference for the final exam. Right, since the final exam isn't due until Thursday night. All right, so things just shifted a little bit in terms of my grading. Right. Everyone have a wonderful and safe weekend. It's hard to believe that it's summer already, the first week of summer, and it really feels like it's spring and it's been miserable. Right. So enjoy your first summer weekend. Hopefully it clears up and everything's nice for you. See you again Monday evening when we'll review previous semester's finals, and you'll have an opportunity to ask me any questions about the course, anything we've gone over so far, the format of the final, any kind of follow-up questions like that. So I'll see you all again Monday evening at 6 p.m.